Assalamualaikum warahmatullahi wabarakatuh. And good day again. Alright, so we meet again in compressible and consolidation of the geotechnic 1. So last time we already see the P sub C, C sub C, and C sub R, the E-log pressure curve. Alright, so that was a characteristic of the soil consolidation. So today, in order to complete our chapter, we need to know the consolidation types. Alright, so last time, okay, let me do the slideshow. Okay. Oh. Alright. So last time we already knew that we interested to know the consolidation for soft clay soil. Soft clay soil. So when we do that, we know about that. So we also know that we interested to know the primary consolidation. Yes, S sub C, primary consolidation. And okay, let's look this figure. So this is clay. Okay, this is clay. And clay have the initial word ratio of E0. E0. And noted that it has a double drainage. Okay, double drainage. So if we need to know the rate of the settlement, bear in mind we need to divide the height of the clay. Let's say this is height of the clay, H. So we need to divide into 2. Why? Because water inside the clay can move or seep out into 2 ways. So the height of the drainage is shortened by 2. Okay, shortened by 2. Alright. So how do we obtain the primary consolidation or the settlement in the primary consolidation? Okay, the settlement. So first and foremost, okay, we need to know the history of the soil. We need to know the history of the soil. So we previously learned how to obtain the pre-consolidation pressure. This is the experience pressure, the pressure that has been experienced by the soil previously. So the soil will remember the amount, the magnitude. If it is high, so it high. High to what? So when we compare the current or the design that we intend to do, okay, P sub naught or the stress sub naught with the additional building stress, okay, let's say. So when we compare this P sub C to P naught or stress naught together with the additional design of the building, so we can define the consolidation types. So if the P sub C and let's say I name this as a team 1 or team A, okay, and team B. So if team A is bigger than team B, bigger, so usually it is a overly consolidated soil, something like that. So however, if the PC and the stress node is similar, especially PC, is similar to the P node or stress node. So it is a normally consolidated. So this one is much more likely OC soil, over consolidated clay soil. Okay, before we go further, we usually interested to know the settlement, okay, settlement at the mid depth, mid, let me rewrite again, mid depth of the clay. Even though it is double drainage or even it is a single drainage, we usually interested to know the compressibility. So we usually wants to define at the mid depth of the clay. Okay. Alright. So we have two types. I mentioned just now, normally consolidated and overly consolidated. So if the P sub C or stress C, okay, pre-consolidation pressure or pre-consolidation stress is equal to current, okay, current stress over burden pressure P naught. Where we define the P naught? Later I show you. Okay, so it is a normally consolidated NC soil, but versus if it is much more bigger, so it is a overly consolidated clay, OC. Okay? And we have an equation. Instead of doing comparison, we have an equation. So if we calculate stress C over stress naught equal to 1, so NC, less than 1 also adopted as NC soil. Okay, so if we calculate stress C over stress naught is bigger than 1, so it is OC. OC. Okay. How we define the stress naught? I do some notes here, simple notes. Okay, stress naught. Okay, so what is stress naught? It is actually the, let's say this is current, because this is the figure of current. So stress naught, any soil formation that we have, let's say we have a sand, clay, silty clay, silty sand, and so on. We just need to know the gamma and the height. Okay, gamma value and the height. Why? Because this will comes as a stress total. Okay, stress total. So let's say I have three different soils. So I might have stress 1 H1, stress 2 H2, stress 3 H3. Okay, so look here. Okay, look at the bottom. Normally consolidated soil, once we calculate the OCR equation just now, stress C over stress naught, and we got equal to 1. So we can use the settlement equation, simple one like this one. So in this equation, we just only need to use the C sub C index coefficient. And if we have the height of, let's say this is clay, let me say this is clay, okay, or let it be at the bottom. So let's say this is clay. So let's say the clay is 7 meter. So we use a full height of the clay, even though if we interested to know at the mid depth. And we need to obtain the effective stress. If you saw the apostrophe here, the prime symbol. Effective stress of current. So how we get the effective stress? So this is total stress. So I hope you still remember total stress is stress effective plus U, i.e. effective stress is total stress minus U. What is U? Pore water pressure. Pore water pressure. So if I adding apostrophe, easily let's say the groundwater table is at the top. So just minus gamma water height 1 to 3 total height. Something like that. So we will obtain the effective stress current. So let's say we plan to build a building, a small building. Okay, very shy building. So we need to calculate the vertical effective stress towards the mid depth of the clay. okay, towards the mid depth of the clay. So we can choose to use a feather method, okay, because you already learned about that. And you also can use a simple 2-to-1 method. So either one, in order to obtain the additional vertical stress. Okay. And not to forget, you need to include the pre-consolidation pressure effective. Right. And okay, if you let me correct the location of the video. If you calculate, let's say you calculate OCR, and however you get the OCR value, how we obtain OCR, stress C and stress naught bigger than 1. Let's say previously you obtained this is 90, and then you calculate the total and effective, you get 78 on. Of course, it is bigger than 1, right? So you need to check because it has a two different equation. Two different equation. One is only consider the recompression index. Another one, you need to obtain both of the index. Okay. Alright, so this is a simple one for the normally consolidated. And this is the overly consolidated. Okay. So let's say this is P sub C, right? And I think this is 10, 20, 30, 40, 50, 57 lah, let's say. Alright. We need to compare what is our stress node plus, previously we already do the calculation of OCR. So the next step is to adding the design stress, okay, and compare again with the pre-consolidation pressure. Compare again. If it is lesser, okay, means decide, okay. So you can use the simple equation but with the CR. However, if you adding up with the stress, you obtain the P sub C or stress sub C is in the middle between the current effective stress to the one with the final design stress. So you need to choose a longer version of the settlement to obtain the settlement. Alright, so this is another representation of the things. Okay, this is the location of the stress prime pre-consolidation, current when add with the additional design loading, still lower than the pre-consolidation, so you use the shorter one. So this is the longer one. Okay. Alright, so you can check the example 8, and also continue with the final exam of 2018-2019 semester 1. Obtain the current stress, and also, okay, just now you already do the plotting P sub C, C sub C, CR, okay, as your homework in past 2 weeks, I think. So calculate the current stress. Okay, calculate the current stress towards the middle of the clay. And then you can use either Fathom or 1-2 methods. And then you start to the decision making to obtain the settlement. Okay, do the OCR, either it is a NC or OC. So I think I stop here. Inshallah, we try to meet online. So if anything you doesn't understand, we can discuss during the online class. So, Assalamualaikum warahmatullahi wabarakatuh. Have a good day. Bye.